divided by the square root of 3. Well, that's kind of fine and fabulous, but for one thing. This number at the bottom is an irrational number. So I'm actually dividing by an irrational number, which is a non-repeating, non-recurring decimal. And that gives me the heebie-jeebies. I can't divide by something that doesn't have an end. So I have to do something about it. Now, some very clever person, I'd love to know who, discovered that if I multiply this thing by 1, except it's a very unusual looking 1. It's root 3 over root 3. In fact, it's the denominator divided by the denominator. Anything divided by itself is 1. If I do that, if I multiply this by this funny looking 1, this root 3 over root 3, this happens. Root 3 times root 3 equals 3, which is now rational. And 2 times root 3 is what? Root 6. Root 2 times 3, root 6. And look, I have a rational denominator. Okay, awesome and fantastic. But let's have a look at this sum. This is slightly more problematic. Okay, firstly, we can reduce this to simplest terms, to simplest prime factors, and we should always do that as a matter of fact, and you will get a mark for that. So here's one I did earlier. I'm going to use that. So that is equal to 3 root 2 minus 2 root 3. And hopefully you can do this by now, or your Casio can. So that's 6 root 2 minus 4 root 3. All very good. Now, some of you owe me a muffin because you're cancelled across a minus sign, okay, which is a big no-no. You cannot do that. We need to do this in some other way. Now, these root signs are different, so I can't add them. There are no common factors, so I can't factorize. I'm going down this tree in my head of possibilities, and I'm coming to a dead end. So what do? When I'm stuck, I don't know what to do. I think about rationalizing the denominator. But this time, I'm going to rationalize with a very special denominator. Root 3, command Z. Root 3 root 2 minus 2 root 3 divided by 6 root 2 minus 4 root 3. I'm going to multiply this by 6 root 2 plus 4 root 3 divided by 6 root 2 plus 4 root 3. What happened here? What is this thing? Why, that's just a 1, isn't it? It's a number divided by itself. Oh, but hang on, Mike. You can't divide a number if there's a cancel over a plus sign. I'm not. This thing is the same as this thing. And more than that, this thing is the difference of square factor to this thing. And why do I use a difference of square factor? Why can't I just use a perfect square? It's not going to pop up. There's going to be a middle term. If it's a perfect square, it's a perfect square trinomial, there's a middle term. If I use difference of squares, there's no middle term because the middle terms cancel. We can FOIL to check. But anyway, 6 root 2 times 6 root 2 is 6 times 6 is 36. And root 2 times root 2 is root 2 squared is 2. That's first. Then outside, 6 root 2 times 4 root 3. And inside, 4 root 3 minus 4 root 3, 6 root 2. So they cancel. And then we've got minus 4 root 3 times 4 root 3. 16 times 3. Look at that. Magically. No rooty things there. Okay, these lines are in my way. Let's do that. All right. So on the top, please remember to use FOIL because there will be a middle term. First, 3 root 2, 3 root 2 times 6 root 2. 3 times 6 is 18. Root 2 times root 2 is 2. Okay, that's first. Outside. 3 root 2 times 4 root 3. 3 times 4 is 12. plus 12. Root 2 times root 3 is root 6. Inside, minus 2 times 6 is minus 12. Root 3 times root 2 is root 6. And last, minus root 2 root 3 times that. 2 times 4 is 8, minus 8. Root 3 times root 3 is 3 times 3. Phew. Yes.
16 is not right. It's meant to be 18.
Where?
You said 16 instead of 18.
Yeah? There? 3 6s are 16 is wrong. Thank you very much. 18. Awesome. I owe you a muffin. Okay. Notice I'll bring you the muffin, but people who cancel across a plus sign will forget to bring me my muffin. 18 times 2 is 36. Plus 12 root 6 minus 12 root 6. Bye-bye 12 root 6. Minus 8 times 3 is 24. All divided by 36 times 2 is 72. Minus 48. 36 minus 24 is equal to 12. 72 minus 48 is 24. 12 divided by 24 is equal to a half, which should be the answer you got in your Casio, because you did that first of all to check.